Hello everyone, I'm Alfian and today we are going to solve the Hackerrank algorithm preparation challenge on the implementation section, and we are now solving the between two sets question. For this particular challenge, we are tasked to there are two arrays of integers and we are going to determine all integers that satisfy the following two conditions. The first one is the elements of the first array are all factors of the integer being considered, and also for the second one, the integer being considered is a factor of all elements of the second array, and then these numbers are referred to as being between the two arrays, and we are tasked to determine how many such numbers exist. For the first array we got 2 and then 6, and then for the second array we got 24 and 36, and there are two numbers between those arrays between the A and B, which is 6 and 12. You might be asking where do the Hackerrank finds the 6 value and then the 12 value from, and the 6 value is the least common multiple or the LCM. LCM is a mathematical operation that finds the least common multiple or the least common multiple that is near both 2 and 6, which is 6 is the LCM, and then for the 12 is the GCD or the greatest common divisor, and then the 24 and the 36 has the same greatest common divisor with 12, so that they both can be divisible by 12 to find the most minimum value or the minimum output. And then we are tasked to find how much counter that is from 6 or from the LCM, and then multiplicated 6 multiplied by 1 and then 6 multiplied by 2 until the 6 has iterated to the 12 as the maximum limit. And then for this one, for the example, the 6 is also the 12 is divisible by 6 and it will return the modulus of 0, and also the multiplication from 6 times 2 is 12, so it's also divisible by 12, so it also returns 0, and then thus the result is 2, or the counter is 2. And then we are tasked to, for the sample input, for the first array we got 2 and 4, and then we need to find the LCM of this array, and also for the array B or the second array. For this one, it's the tricky one because it's different from the example, because we have 3 elements instead of just 2 elements in the array of B, and then this is the sample output of 3 is the LCM of the first array and the GCD of the second array. And then without further ado, let's solve this by finding the GCD. Let's select this one. For this one, we can use the recursive method, the recursive function from my function, and then we can change it to GCD that calculates the GCD using the Euclidean algorithm, and it's recursive, which means that it will run the function itself inside the function. and so it's called the recursive. Let's copy this, and then we can write it right here, and it's okay. It's considered a function helper. Since we are using TypeScript, we determine the first and second parameter using the number or the integer, and then the output is also number. So if b is strictly equal to 0, then returning the a value, and then this is the recursion function that will run the function itself again until the if statement is true, and that way the function itself will stop. And for the LCM, let's find this, the LCM. We can use the math.js as the reference, and this is the LCM function. We can copy this right away and just using define the LCM function, so which is the first parameter is a number, and also the second parameter is also a number, and then output is also a number. And since it's absolute, we can use the built-in JS absolute function, which is the A and B. We can use the arrow function, constant LCM, that takes the parameter, and then this is the math absolute, finding between A times B. So if either or both are negative value, then the absolute will take it as the positive. Regardless of the negative value, it will also return as positive value. And then for the GCD function, we can just write it right here with the Control D and the GCD. So the basic LCM function already completed, and then we can, since the second array, we are going to solve or find the second array which has 3 elements inside. So we can use the function, or using the arrow function, GCD array, and then that takes the number array of numbers, and then the output also a number. We can implicitly return using the reduce function with using the accumulator as the parameter, and then the current iteration, and then implicitly return calling the GCD array of the accumulator and the current function. And then we can write our main function here, and it takes the first parameter as the array, and also the second parameter also the array, and then we find the result of the LCM from the first array, which is the constant, store it in the constant, call the result LCM, and then calculate the LCM with the lowercase LCM, and then that takes the array, but since it's a different kind of LCM, then we can use the constant LCM array, an array of number, then output as the number using the array reduce. The same thing as the GCD array function with the accumulator and the current, and then call the LCM function with the accumulator and the current iteration as the parameter, and then implicitly return it. Then we can call the LCM array that takes the parameter of the array A, and then for the second one we can use the constant result of the GCD array from the GCD array function we declared earlier, and then we can determine the counter enter 0. And then let me explain it a little bit about the counter. Let's say if we have the LCM of 4 from the calculation, and then the GCD is 16, we need to find the counter from both GCD and LCM. So we need to check if the current iteration, which is divisible by 4, and if it returns 0, then we can count it up by 1. And then for the second iteration, which is 8, because why is it 8? Because 4 times 2 and then times 3 and then times 4 based on the current iteration. If it's 0, then count it by 1, and also if it's 0, then count it by 1, check if it's 0, and also you guess it, which is to check if it's divisible by another 8 plus 4, which is equal 12. 16 modulo 12 is not equal 0, then it will not count anything. And then for the final part or the final iteration, to check if the 16 modulo by 16 is equal 0, then it's also true. Then the counter is 3. And then the iteration will stop because the first LCM multiplier already hits the maximum of the GCD, and then the iteration will stop. So the counter returning the 3 from these values that we got from the modulo check. And then using the for loop, we can use while or for loop, but for the sake of the tutorial I'm using the for loop, using the let counter, and then this is the multiple. The multiple is equal the current result of the LCM. And then we can use this as reference for the multiplication. And then the second statement, which is as long as the multiplication is below or equal the result GCD that we declared earlier, and then we can continue iterating multiple added by the result LCM. So that is why I already declared like right here, and it's 4, and then for the second iteration 4 added by 4, which is 8, and then added by 4 again, which is 12, and then added by 4 again, which is 16, and then the iteration will stop because the for loop already satisfies the statement on the second statement. So we can check if the result GCD is divisible by the current multiplication of the result LCM strictly equals 0, then we can edit the counter by 1, and then if it's not, then return counter of the current counter, so it's not added by 1. And then let's run this code to see if it works. It seems that we have an error. Let's move the return counter outside of the for loop clause. Let's run this again to see if it works. Let's submit this to make sure if it really works. Okay, so it's a success, and then we can improve something here. So if you are concerned about the recursive call for the GCD function, or if the input array or the array of LCM or either LCM or the GCD to find the LCM and the GCD, if you're concerned about it, then we can use the while loop, and you don't have to worry about this because it's not going to recursively call the function itself, but instead the while loop also functions the same as the recursive call using the Euclidean algorithm. And then this while loop is not using recursive call, but instead using the while loop, using the array that consists of A and B to check. As long as the B is not strictly equal to 0, then we can count it right here, declare the value as the array, and then we swap the B to the A position, and then using the modulo operator to calculate the A with the B to see if it's divisible, and then return the remainder from the A modulo B, and then returning A. So let me explain it for a moment. So for the while loop, let's say while 16, the B value that we used earlier using the 16 is not strictly equal to 0, then we can use the A, which is 4, and then 16, and then equals the 16 and then the 4 to check if it's divisible by 16, or the remainder, and then returning the A. But since it's since the second value or the B, let me explain it. So the while loop also iterating again as the 16, and then 4 modulo by 16 is equal 4, and then it only swaps the position by itself, and then we are rotating it again at 4, and then takes the 16 because 16 already on the A position, and then times, oh not times, but to check if it's divisible, and then it's 4 16 modulo 4, and then the result is stored right here, 4, and then it's 0, and then since is 4 and 0, then the while loop will stops because the B element or the second element inside the array is 0, is equal 0. Then the while loop stops and we are returning the A value, which is the destructorization from the array itself. So that is why the GCD of of 4 and 16 is equals 4. We can use the factor 3 to see if the GCD value is also returning 4 between 4 and 16. So we are using the prime number of 2, and then the result that 4 divided by 2 is equal to, and then for the 16 we are going to use the prime number of 2, and then the result is 8, and then 8 divided by is divisible by 2 and also returning 4, and then divided again by 2, and then the returning is also, the returning value is 2, and then it stops with the factor 3 calculation, and then we got the 2 exponent of 2 from the 4, and then for the 16 is 2 exponent of, this is 2 1 2 3 and 4 as the final result. So that is why it's 4. 2 exponent by 4 is equal 16. So for the GCD value of the 4 and 16 is equals to, since they both are using the 2 exponents for the GCD value from the factor 3, we only get the lowest value or the lowest exponent from the similar exponents right here. So that is why the minimal exponent is 2, and so that's why the GCD of 4 and 16 is equal 4. Okay, so that's about it. I hope you understand this explanation. If you have any other questions or if you have any better solutions, you can write in the comment section. I hope you have a great day, and I will see you on the next video. Goodbye.